Hello, um, good day. So today we'll be talking about data types, variables, and operators. As we know, when you are writing programs, you need to work with data. You need to store data, retrieve data, and use data in your calculations. So now we'll pick each of the data types, variables, and operators and talk about what they are and how they are used in programming. All computer programs work with data. They take input, as you know, a computer is an input process output system. They take input, process it, and produce output. To handle data effectively, a programming language must know the type of the data, how to store that data, and what operations can be performed on that particular data. In this lesson, we introduce three fundamental building blocks of programming: identifiers, variables, and constants, data types, operators, and expressions. Understanding the following concepts is essential for writing correct and meaningful programs. Now, let's start with identifiers, variables, and constants. Identifiers, an identity. What gives you identity? For example, you have your name, right? That's what gives you your identity. So now in programming, an identifier is the name used to identify a variable, constant, function, or class in a program. The name that we are going to use to identify our variables, constants, functions, or classes in our programs. It allows us to refer to stored data or program components by their name, right? So it makes it easy for us. The fact that we all have names, that's why it is easier for us to refer to each other by our names. Rules for naming identifiers. So now, these identifiers are named, right? Then there are rules for coming up with a name for identifier, right? So these are the following rules for naming identifiers. So your identifiers names must begin with either a letter or an underscore. A letter or an underscore. And take note, for Python programming language, underscore is the only valid character that is not a letter or a digit. The only valid special symbols that you can have in your name is the underscore. You will see as we go through the remaining rules. First rule must begin with either a letter or an underscore. Can contain letters, digits, or underscores. These are the valid characters you can have in your names. Letters, digits, underscore. Underscore is the only special symbol you can have. You cannot start with a digit. As we said from the rule number one, it must begin with either a letter or an underscore. So you can't start with a digit, even though a digit is also a valid character in an identifier name. It cannot contain spaces or other special symbols. The only special symbol it can contain is what? Underscore. Nothing else. They are case sensitive in Python. Case sensitive means uppercase is different from lowercase, or capital letter, small letter. They are not the same. So name starting with capital letter, uppercase letter N, and name starting with lowercase letter n are not the same name. Cannot be reserved keyword. So programming languages, they have reserved keywords that they use. So it can't be any of these reserved keywords. So for example, if, for, while, true are examples of reserved keywords in Python. So these reserved keywords cannot be used as variable names. Examples now. We have the following variables that we've named. The first name identifier for the data that we are storing now, in this case. Student name. You can see that is the identifier. That is the name that we are going to use to refer to the data John. You can see John is a word. We have another age 20. 20 is what? A number. We have another total marks 85.5. 85.5 is a decimal number. We'll still get to data types and we'll talk about the different data types that we have. So you can see these are valid names, right? For identifiers. You can see that we are using underscore to separate two words. You have student name. So since spaces are not allowed, we can use underscore. Example, another example is total marks. Underscore will help you separate different words in your names. Now, let's move to variables. A variable is a named memory location that stores a value which can change during program execution. What do we mean by this? A named memory location. So, we've talked about naming, right? Now, variable is a memory location that you have given a name. So, you have a memory location where you have stored your data. Then you give that memory location a name because all your data will be stored in a particular memory location, right? You have your phones now. When you take pictures, they go into your memory. That's exactly what I'm talking about here. So that memory location that you're going to store your data, you are going to name it. So that's how you have variable. So variable is a named memory location that stores a value, which can change during program execution. You will soon understand why this last part, this later part is important. Variables can change during program execution. So we'll look at another concept, constants, which are like variables, but their value can't change during program execution. As you can hear, constants. So they are constant. They remain the same throughout program execution. In Python, variables are created automatically when you assign a value. So when you have your name and then you assign data to that particular identifier, you automatically have created a variable. So you don't need to declare their data type explicitly. Python is dynamically typed. So for variables, each value you are storing, right, in a memory location will have a data type. There will be a type of that for that data, right? It is string, which are words, text, or numbers, or some other data types, right? So, but in Python, this data type is dynamically typed. It's explicit. You don't need to specify it. Python would know the data type itself. So examples that we have, the ones that we've seen before are also variables, right? So we have name, which we store Sarah in. We have age, 22, and GPA 4.57. You can see that our identifiers, the variable names in this case, they follow the rules that we specified uh, above. Explanation. Name is a string variable. So characters, characters that are together, sequence of characters, maybe a word, a text, you're going to understand a paragraph, they are called strings. Then a whole number is called integer. That is the data type, integer. A decimal number is float. So those are the different data types that we have. We still have more. So when we get to data types, we'll talk about more of this and we expand on these ones. Now, variable assignments. Variable assignment is when you just have your name and then you assign a data to that name. So it's like you have a memory location, you have named it, so you have your variable, and then you pick a data, a value, and then store it inside. So for example, you have x is equals to 10. X is the name that is given to that memory location where you are storing this value, this 10 value. So anytime you want to refer to that memory location, you refer to it by its name, which is x. Same with y. And then you can see you are creating another variable, another memory location that we want to store a value in, which we have named sum. So that memory location that we named sum, what is the value that we want to store inside? It is the addition of the value of x and y that we want to store there, the sum. So sum is going to be 30. So this last part is how you print in Python. So you can just print a string followed by a variable. So this is going to print sum equals 30. We'll still run the programs, we'll run the codes. So but let's go through it first, then we'll run the codes after. A constant. So we are done with variables. Now we are moving to constants. The difference between variables and constants is that constant, a constant is a value that does not change during program execution. For a variable, the value can change during program execution, but for a constant, the value does not change during program execution. Python doesn't have a true constant declaration like other programming languages. So, but by convention, constants are written in uppercase to indicate that they should not be changed, right? Now, Python does not force you to have like a true constant declaration whereby when you have declared something as constant, when you try to change the value during program execution, you are going to run into an error. So, but there is a convention where your constant declaration will be in uppercase letter so that anybody that is reading the code or you yourself will know that this is a constant. I will not try to change the value in your program. So example, pi, pi is, 20/7, and that's a constant. Pi is always 3.142, or it's longer than that. Max students, this is indicating the maximum number of students that you can have. So that's like a constant. It should not change. So like it's like a quota. Now, let's move to data types now. We look at primitive data types. Data types define the kind of values a variable can hold. The kind of values, variables, they hold values. They are like containers where you store something inside. So the kind of values a variable can hold and the operations that can be performed on those values will be determined by the data type of that particular variable. So data types define the kind of values a variable can hold and the operations that can be performed on those variables. Operations, for example, a data type of integer, which is a number, you can perform addition operations, subtraction, multiplication, and so on and so forth. Unlike string, which I told you is just a sequence of characters or text, you can't perform multiplication on that, you can't perform division on that. So those are the operations. You can perform some other operations on them too. So we'll get to them, inshallah. So that's data types in a nutshell. Now, Python supports several primitive or basic data types as shown below. We have the integer, we have the float, we have the string, and we have the boolean. Remember the boolean from your CSE 111, right? So this is where you start understanding why it is necessary. So integers represent whole numbers. So int, short for integers, represents whole number. Example, x equals 25. 25 is what? An integer, is a whole number. Float represents decimal or real numbers. So you are doing maths, you understand decimal or real numbers. GPA equals 4.25. So the data type of GPA now, since it is holding 4.25, that's the value that's stored in it, the data type is going to be float. Then str, string, represents sequence of characters, text. An example is name equals to Alice. And strings will always be in quotes. You can see that unlike integer floats, they are not in quotes. But string will always be in quotes, which means even if you put a number, an integer or a float in quotes, it becomes a string. So if I say quotes 25 close quotes, that is going to be a string. So anything you put inside quotes, it does not matter. It's going to be a string. Now, the last basic data types, primitive, is bool. Represents logical values, true or false. So it's what we just use to represent true or false. Remember from your CSU 111, you have 1 for true, 0 for false. So we just use true or false with uppercase T, uppercase F. Int, integer, int. All numbers positive or negative without decimals. So integer, that's just it in a nutshell. Simple, right? An example, a equals to 15. 15 is an integer. B is equals to -8. -8 is an integer, positive or negative, including 0 integers. Now, float, numbers with decimal points or exponential notation are floats. So once you have decimal point, you're automatically a floating number. Example, height equals 5.9. Temperature equals -2.5. So floats like integers covers both positive and negative side of the numbers. Then string, str, text enclosed in single or double quotes. As I've said, anything in quotes becomes a string automatically, no matter what. Once you put it inside quotes, it's a string, it's just a text. Strings can be concatenated or sliced. So these are examples of the operations you can perform on strings. Concatenation, you can join two strings together. Or slice, you can cut part of the string, you can cut it away. So example, we have name is equals to Grace. Grace, that's a string. Then we have message is equals to welcome, which is a string with space. Then plus name. This plus here is not the addition plus because we are working with string now, not integers or floats. So this plus is concatenation. That's how you concatenate strings in Python. In other programming languages, they use other notations, but plus is general. A lot of most programming languages they use plus. So this plus means concatenation, which means what? It is joining two strings together. Now the first string is welcome and space plus name. You know what's the value of name? Grace. So it's joining welcome space plus Grace. So what you are going to have when you print this is what? Welcome Grace. When you print message, that's the variable, and the value is what will be printed. Now Boolean. The last of the primitive data types. That's just two values, true or false, on or off, right? 1 or 0. So, but it is true or false that we use in Boolean, not 1 or 0, or on or off. So now, it is often used in logical operations and decision making. Example, is logged in equals true. You can print is logged in to print true for you. So you can see that true is not in quotes. Once you put it in quotes, it becomes what? It becomes a string, right? So take note of that. Let's move to the operators. Operators are special symbols or keywords. They can be symbols, they can be keywords, depending on the data type you are working with, used to perform operations on data. So data are called operands. For example, you have the plus, the addition operator, the subtraction, multiplication, division. This is equality. Equals equals is equality operator. And is your logical and, from your Boolean algebra. Same with or. So these are examples of operators. So we'll look at them by their categories. So we have arithmetic operators to look at first. These are used for mathematical calculations, as we all know. So we have the addition, subtraction, multiplication, division. These are the normal arithmetic operators that you all know, that you've been working with. And you can see their symbols when it comes to Python programming language. Now, let's look at the ones that you are not familiar with. We have the floor division, you have the modulus, and the exponentiation. You are familiar with the exponentiation, right? But how it is represented in your normal mathematical notation is different from how it is being represented here. So let's start with the exponentiation. Exponentiation is when you raise a number to the power of another number. So if you want to do 3 raised to power 2 in Python programming language, that will be 3 star star 2. So that is going to be equals to 3 raised to power 2. So that's exponentiation, right? Now, examples that we have here is x is equals to 10, y is equals to 3. So that's 10 star star 3, which means 10 raised to power 3, and that will give you what? 1000. Now, let's move to floor division. Floor division with the double slash. So floor division, what does floor division do? Floor division will return the whole number part of a division, right? So 10 divided by 3 will give you what? 3.33333, right? You see that whole number part of the division is what floor division will return. It does not care about the remainder or the decimal part. So 10 floor division 3 will give you 3. Now, modulus is the complement of floor division. Modulus will return the remainder. That's division part, remember, the remainder. So 10 divided by 3 will give you what? 3 remainder 1. So it's going to return 1. So that's modulus. Modulus returns the remainder of a division. If the remainder is 0, which means nothing, like 10 divided by 2, it's going to give you 5. Remainder 0. So it will return 0. And that is the symbol for its percentage for modulus. Now, examples, you can see examples here. X 7, y is 2. So if you are printing x plus y, that's 7 plus 2. And that will print what? 9. And if you are printing x exponentiation y, that's 7 raised to power 2. And that will give you what? 7 squared, that's 49. Now that's about arithmetic operators. Let's move to relational operators. comparison operators. You can call them, you relate or compare two things together. So you can call them one of those things. These are used to compare values and they return true or false. So relational or comparison operators, their operation always return what? They always return a boolean. A boolean, true or false. A boolean data set. Like unlike arithmetic will always return what? Integers or floats. Now, let's start with the first operator. This is the double equal operator. So this is used to compare equality. Now, don't mistake the single equal symbol with the double equal symbol. The single equal symbol, like we have here, is used to assign a value to a variable. So you take a value and store it inside a named memory location. That's what we use the single equal to for. Now the double equal to is used to compare two values. Used to compare if they are equal. If the two values are equal, if they are the same. You understand? So now, for example, we have x as 10, y as 3. So if we check that, is 10 equals to 3. That's double equals. So if you want to check if two values, if two variables, you want to compare them, are they equal? That's when you use double equal sign. Right? X equals y. X is not equals to y. So you get false in the end. Remember that the result of a relational or comparison operation is always a boolean, either true or false. So 10 is not equals to 3. That's false. Or if it is 7 and 2 we are using, is 7 equals to no, that's false. Now, the next operator is not equal to. You can see that exclamation mark is basically just saying not there, right? So exclamation mark is the not when it comes to programming language. So you remember your not. So not equal to. So you are checking if two values are not equal. So if they are not equal, you are going to get what? True. If they are equal, then you get false. Then we have the greater than, we have the less than. We check if a value is bigger than another value or if a value is less than another value. So the tricky question here is 10 greater than 10? No. So that's going to give you false. Is 10 less than 10? No. That's also going to give you false. You understand? Then we have the greater than or equal to, and then less than or equal to. So this adds one more step on your greater than and less than. It checks if the numbers are greater than, the first number is greater than the second number, or if they are equal at least. So if it is greater than it or equal to it, you get true. So the example that I gave of 10 and 10, is 10 greater than or equal to 10? 10 is not greater than 10, but 10 is equal to 10. So that gives you true. You can see that there is or there. Remember, your or, you just need one of the conditions to be true. So is greater than true? No. Equal to, is it true? Yes. So you have one true, then you get true. The only time you are going to get false is if both are false. Greater than is not true, equal to is not true. For example, 3 and 7. Is 3 greater than 7? No. Is 3 equal to 7? No. So that's false. Same thing with less than or equal to. I hope you are following me. So let's look at some examples too. So we have 5 and 8 here. The first comparison we are making is to check if 5 is less than 8. X is 5 now, and y is 8. 5 is less than 8, so that is going to give you true. We then check, is 5 equals to 8? 5 is not equal to 8. That's going to give you false. Sorry, is 5 equal to 8? Yes. 5 is not equal to 8. It's going to give you false. So instead of doing equal here, if we do not equal, 5 not equal to 8, that's going to give you true because 5 is not equal to 8. Right. So let's move on. Now, logical operators. So we've looked at Boolean, we looked at relational comparison. Then we look at logical operators. Logical operators are used to combine or modify Boolean expressions. So, your comparison operations, you can combine them using the logical operators. So your logical operators, remember, you have your and, or, and not, the basic ones. I know we talked about XOR, NAND, NOR, and all of that. So now, AND, OR, and NOT. Those are the things you need to pay attention to for this particular course. AND is true if both operands are true. Remember, from our AND is only true when the two conditions that is joining are true. So same thing here. Same thing with OR, same thing with NOT. Now, example, x greater than 3 and y less than 10. If x is greater than 3 and y is less than 10, that is the only time you are going to have true, right? You're going to have true. Now, x is 5, y is 8. I'm just giving you an example here. X is 5, y is 8. Is x greater than 3? Yes. And is y less than 10? Yes. 8 is less than 10. 5 is greater than 3. So you can just do your truth table. If you don't want to get confused, you can just do your truth table to try to evaluate this, right? So if you have true and true, you know that it's going to be true. If you have true and false, that's going to be false because that is AND that you're working with. And you only get true if both operands are true. Or you only get true if at least one operand is true. You just need one of the operands to be true for it to be true with all. The only time it is false is when both operands are what? Are false. You can remember that. And not is just reversing the Boolean value. Whatever you get um, from an operation, not will do what? Not will reverse it. So if you get false, not will reverse it to what? To true. X greater than y. X is 5, y is 8. Is 5 greater than y? No. So that's false. And then not false will give you what? True. Not true will give you what? False. So these are the examples that we have here. X is 10, y is 5. Is x greater than 5 and y less than 10? True. X is 10, so 10 is greater than 5. Y is what? 5. 5 is less than 10. So that's true and true. True and true is what? True. So that's 1 and 1. Not is x equals to y. X is 5, y is 10. Sorry, x is 10, y is 5. They are not equal. So that is what? False. They are not equal. But because you now have not there, not will do what? It will reverse it. So not to change false to true and true to false. Since it is false in this instance, it is going to change to true. And you have what? True. That's what will be printed. So this prints that you're looking at is how we print something out in Python. We'll get to how we collect input from user in Python too. So this is how you just print out outputs in Python. So now assignment operators. So you have your normal simple assignment, When you assign is you take a value, you store it in a variable, right? So you have your simple assignment with a single equal to. Now, we now have other assignments that are different. So now you have plus equal, minus equal, multiplication equal, division equal, percentage equal. So all these are what? They are arithmetic operators that are combined with the assignment operators, and they work as thus. Plus equal will add and assign. So whatever is on the left, on your right, you evaluate it first. Whatever you get for that result, you are going to add it to the original value in that memory location in the variable. Then you will store it in the variable again. I know it's confusing. So let's look at an example. X is equals to 5, right? Then you have x plus or equals to 3. So whatever is on the right side, which is just 3 in this instance, it can be a lot of things. Whatever is on the right side, you evaluate it first. Let's say we evaluated everything on the right side and we got 3 in the end. Then you take that 3, you add it, because this is add and assign. You add it to the initial value of x, which is 5, and then you save it in x again. So you take 5, you add it to 3, it will give you 8. Then you take 8 and store it in the x variable. You understand? So it's like you are replacing the value in that memory location with this new value by adding whatever the results you have to the value that was already there. And the same thing goes with subtraction. So you subtract from the value that was there before. Multiplication, you multiply Division, you divide. Modulus, you understand. You do the remainder. You find the remainder and you add. If you find the remainder from and you store it inside the location, memory location of x. So we have examples here. X equals 10. X is 10 at first. Initially, that's the value that we are storing in that memory location. Now, the next thing we do is x plus or equals to 5, which means we take 5, we add it to the initial value of x, which is 10, and then save it in x again. So that's 5 plus 10, 15. Then you save 15 in x. So x is now what? 15. Then we move down. We now have x multiply and assign equals to 2, which means you take 2, you multiply it with the initial value of x, the value that is there, which is 15 now, and then you store that value in x again, which is 2 multiplied by 15, and that will give you 30. So the latest value in x is what? Is 30. So when you print x, you are going to print what? 30 at this point. So it starts with 10. We replace the value with 15 by adding 5 to it. Then we replace the value with 30 by multiplying it by 2. So operator precedence, like your board mass, right? So we have operator precedence. We have operator precedence for our Boolean algebra too. So when multiple operators appear in an expression, precedence determines the order of evaluation, how you are going to evaluate them. And the number one, the first level, is parentheses. This thing that you call brackets is parentheses. So an associativity from left to right, which means if you have multiple parentheses, you evaluate them from left to right. So, and that's the first thing you evaluate. The next level is the exponentiation, the raised to power, the power. So that's the next thing you are going to evaluate. And you evaluate it what? Right to left, because the power is what? The power is always on the right. Remember. So if you have 4 raised to power 2, that raised to power 2 is going to be on the right. Now, the next level is your multiplication, your division, your floor division, and your modulus. So they are on the same level. So if you have multiple of them, you evaluate from what? From left to right. You evaluate them as you see them. So from left to right. Plus and minus, addition and subtraction, they're on the same level too. You evaluate them from left to right. So if it is minus, you see first, that's what you evaluate. If it is first, you see first, that's what you evaluate first. Then we have our comparison operators: less than, greater than, less than or equal to, greater than or equal to, not equal to. So they are all on the same level too. And you evaluate them from what? From left to right, as you see them. So then we have our knots. Not, you evaluate from right to left, and not has a higher precedence over and or. Remember from our CSE2 is the same thing. So then followed by and or, which you evaluate from left to right as you see them. Followed by the equal to, the assignment, and all the compound assignments. So the assignment is what you do last, right? The assignment and the compound assignment is what you do last. So you must have evaluated everything, or the expression first before you now do the assignment or compound assignment. You remember the compound assignment, the one that we just talked about, the plus equals to, minus equals to, and the rest. So example, we have a variable which we want to store a value in, and the expression is what? 5 plus 2 multiplied by 3. From your precedent, you do what first? You do multiplication first, because multiplication has a higher precedence when compared to addition. So it's going to be 2 multiplied by 3 first. Then you are going to add 5 to it. Then you are going to assign it to result. So what you are going to have in the end is 2 multiplied by 3, which is 6. 6 plus 5, which is 11. Now, for the next example, we have parentheses. So you have to evaluate parentheses first. So anything inside the parentheses, you have to evaluate it first. So you do 5 plus 2 first, because they are in parentheses. Then the result, which is 7, you multiply it by 3, and that will give you 21. So I hope you understand the difference. I'm sure you already know this. This is just your basic mathematics. Now let's move to expressions. We're talking about expressions. What do we mean by expression? An expression is any valid combination of the following: constants, variables, and operators that evaluates to a value. So any valid combination of constant variables and operators, you know your operators, that evaluates a certain value, that is expression. So 5, 10, x is 5, y is 10. Then z is x plus 2, x plus y multiplied by 2. That is an expression because this combines what? It combines constants, which is 2. That is a constant, right? It does not change. And variables, x plus y, and operators, and in a valid way, because this is valid. This is a valid expression. And it evaluates to a value. This will evaluate to what? 25, because you have what? Y, which is 10 multiplied by 2 first, and that will give you 20. Then you add 5 to it, and that will give you 25, your operator precedence. So that's an example of expression. Expression does not have to just be arithmetic. You can see we have arithmetic, we have relational expressions, we have logical expressions too. So lab activities. For this lesson, we declare and use different data types. You see, this is an example. And then implement expressions using operators, arithmetic, relational, logical. Yeah. For arithmetic now, we can calculate total and average marks. For relational, we can check if a student passed or failed by using their marks, their score. Logical, you can test multiple conditions. You can add multiple conditions together. So you can solve arithmetic and logic problems in code. Find the area of a circle. For example, check if a number is even or odd. Determine if a year is a leap year. Now, let's write some code for these lab activities. So let me try to open up. Okay, let me see. So let's come here. I'm going to create a new folder here for SEN 111. So in this folder, I'll create a file, a Python file. So okay, so let's go over this. If you've not installed Python, you don't have Python on your system, you can easily do that by going to Microsoft Store. So you open Microsoft Store and search for Python. You can see you will find Python 3.13, find Python install manager. You can install Python 3.13, so you can just click on install, or you can install Python install manager. So this will help you take care of installing Python. So when you are done, you can open your VS Code like this, and then you come to terminal, new terminal. You open up a terminal after you install your Python. Then you type Python dash version, I think. So if you get something like this shows that what you have Python installed on your system. If it tells you that command not found, that means Python is not installed yet. So you have to install it with this method. If you're on Mac, you can check online for how you install Python on your Mac OS, right? But this is for Windows user. So it's very easy. Just click install and let everything go as it's supposed to. So I'm creating a folder, and then I want to create a new file, variable. So when you want to create a Python file, you give it a name. Remember, even when you are naming the file of a Python, try to follow the identifier naming rules. right? That will really help. So you can you should not have space. Try not to have space. So variable examples now. See, dot the extension is pi. Remember, your files, each of them, they have extension. For your image, for example, your image is .jpeg, .png, and so on and so forth, right? For your videos, you have .mp4, .mkv, .mov. For your audio file, you have .mp3, .aac, .ogg, and all of that. So for Pythons, the extension is .py. So anytime you are creating a Python file, always end it with .py, right? So you can see when I added .py, there's already an icon, a Python icon behind it, letting us know that this is a Python file. So save. Now you can now write your code here. You can start writing your code here. So I can say x is equals to 5, y is equals to 10, like that. Then I can print the value of x is, the value of y is. Then I can perform operations with the variables, right? I can do x plus y and print the sum. Variables can be of different types, as we've said. You can have other variables, name, Alice, age 30. You can print name, you can print age. You can change the value of a variable. That's the point of a variable. Value can change, throughout your program execution, unlike constant. So we are changing x value to 20 now. The new value of x is, it will print it. So this is how I print. You can see that I'm printing anything that is word, that is like a sentence, text. I'm printing it in quotes. Then there will be a comma after. Then I'll print the variable that I want to print. I can print more after. Just separate with comma. You can see. Just separate them with comma, and you can print a lot of things. So if you want to print a variable, you just put the variable name there, and it will give you whatever you want to print. So now I can also do boolean. I can print, for example, x less than y. I can print that. I can print x greater than y. When x equals to y, I can print x not equal to y. All the operators, so I can work with them. So for example, let's look at something, the modulus and floor division. So lines, let me explain this. Lines that start with hash, they are called comments in Python. Any line that's starting with the hash symbol, this whole line is a comment. It's not part of the code. It's not a code. It's just an explanation of maybe what the code does, right? So it's not part of the code. It's not going to be executed. So that's just a comment for people that comes to read the code to understand that, okay, this is what this part is doing. This is what this part is doing. They are not code in themselves, so they are not going to be executed. So using hash, we have a single line comment. Floor division and modulus. You can see floor division modulus. So now this is a single line comment. You can have comments that spans multiple lines. You can see that this is just one line. If you want to have comment that spans multiple lines, you are going to use triple quotes. You can see you have what? Three quotes from the beginning to the end. So with this, I can have comments on plenty lines. The beginning has to be white, like what? Single quotes, and the end, sorry, triple quotes, and the end has to also be what? Triple quotes. So I can break this into plenty line. So you can have multi-line comments like this. You can have single line and multi-line comments. can see this spans how many lines? One, two, three, four. 4 lines. So you are going to demarcate it by having 3 quotes from the beginning and 3 quotes at the end of your comments. So everything between these triple quotes, they are what? They are comments. Alright. So I just want to show you that. Now, when we are done, you can run your code. For example, there is a play button here that can allow you to run your Python codes when you are using VS Code. But you have to have installed some extensions for you to be able to do that. So for you to do that, you come to the extension place here, come to the extension place here, and you look for Python, search for Python. You need to have what is it called for this? Internet, just to download this, right? So once you have internet and you downloaded it, you don't need internet anymore. So Python debugger, Python, PyLance, PyEnvironment. So these first four, just installed all of them. You might need to restart your VS Code for them to work. Now let's go back. So you can easily press this to run your Python file. If something is wrong, let me try to see. Select Python environment. Okay, it seems like you can't find my Python. Can't find my Python that was installed. I don't think you should have this problem if you follow the Microsoft stuff to install your Python. So if you can't use this, there's a manual way to run your Python code, to run even almost all your codes, regardless of the programming language. Each programming language will have their own uh, syntax of running it. So now this is what I'm going to do. I'm going to go into the folder. I open this, you can see I right clicked and I open an integrated terminal. So I'm in the folder where my Python file is. You can see documents, CS211, NDCN, SCN111. So this is SCN111. And inside it, I have these variables, variable examples.py. You can confirm that by doing ls. So ls brings that I have this file here. Now, I can use the Python interpreter from the terminal. You know that Python that we checked. And then just give it the name of my file, Python variable examples.py. And I click enter. And it will run the Python code for me. You can see it has run the Python code for me. And we have the value of x is 5 and the value of y is 10. And this is the first print statement, output. Then we have the value of y is 10. This is the second output statement. Then we add y and x together and save it inside sum. And then we print the sum of x and y is sum. And what is stored in sum? 15. Then we print we created the variable name and we stored Alice inside, a string. We created the variable age and we stored 30 inside. And we printed them, name Alice. You can see I just did what? Name. And then I put the name after age, comma, age. So that's just how you print. You use a comma to separate the different things you want to print. So, and we kept moving on. Then we reassigned x to 20 because x is a variable. It can change, obviously, right? So we assigned x to 20 and we now print the new value of x, which is now 20. Then we did all these comparison operations. X is 20, y is 10. So we just compared. Is x less than 10? False. And see, is x greater than 10? True. Is x equals to 10? False. Is x not equal to 10? True. X is not equal to 10. Then we did floor division. So you know, y is what? 10. X is what? 20. floor division of y by x. So y is 10, x is 20. 10 divided by 20. When you do floor division, it's going to remain 0. That's what it's telling you, right? So now you are doing modulus um what is it called? Sorry, floor division. The whole number is 0 because 10 divided by 20, 10 floor division of 20 will give you what? 0. Let's look at it. 10 divided by 20 is what? 0.5, right? The whole number part is 0. So that's why floor division is returning what? 0. And modulus of 10 by 20 is going to give you what? 10. Because that's the remainder. 10 goes in 20. Sorry, 20 goes in 10. How many times? 0. What's remaining? 10. Is remaining 10. Right? So that's why you have modulus that is 10. So now we can do a lot of things combining these comparison operators using our logical operators and or and not. You understand? So you can do all those practice at your own time. If you don't have a computer, you can do this practice. You can use your phone. There's a PyDroid app. There's a PyDroid app for phone that you can write Python and run it. Python codes and run it. All right. Uh, you can look at the self-assessment questions and try to answer them. So let's move to the next topic, control structures. Control structures. So this is the first part of the control structures. And I think after this lesson we can stop. I think your exam should not go outside of these 5 weeks. Now, control structures. What are control structures? We are going to look at sequence and selection. There's another part of control structures which are loops, iterations. So we look at sequence and selection. Control structures are fundamental in programming as they define the flow of the execution, the flow the flow of your program execution. You know your program will execute, as you can see from our code here. Our program was getting executed just straight down, one line at a time. So control structures will help you define how your program gets executed, the flow of how your program is going to get executed. These control structures, they control how different parts of the program are executed based on conditions and logic. You set some conditions and logic to control how the different parts of your program are executed. So far, so good. We've not had to use any conditions or logic, right? It's just a straight down approach of execution. So now for this lesson, we'll focus on the sequence and selection control structures, which are the foundation of decision making in programming. They are the backbone of decision making in programming. You make decisions, right? That's especially why you have your Boolean, your logical operators, right? Your relational operators. You have them so that you can use them to make decisions based on conditions. There are conditions there. So the result of those conditions, remember, your relational operators and combining them with your logical operators will either return true or false. So you can now make decisions based on the result of that particular computation. So if it is true, you might want to do something. If it is false, you might want to do something else entirely. So that's you making decision. Now, program control flow concept. Program control flow refers to the order in which individual statements, instructions, or function calls are executed or evaluated in program. So control flow, how your everything you've written, how the order by which they get evaluated or executed. Understanding how the flow of control works is critical for creating logical programs. So this is very important. Control flow is determined by structures that dictate sequence and selection. For sequence now, instructions are executed in the order they are written. That's by default. That is exactly what happened now. Instructions are executed in the order they've written. So line 1, line 2, line 3, line 4, line 5, like that. So they'll be executed from top to bottom in the order that we've written them. So that's sequence. So that's by default. Now, selection. This is where we make decision. Where we now determine that, okay, this is the part we want to execute and not this part based on some conditions. So the program can choose between different parts based on conditions using conditional statements like if else, and match case. So these are the reserved functionality of Python. If else, and match case are the conditional statements we can use to make decisions in Python. So now sequence structure, as I've explained, is just straightforward. The sequence structure is the simplest control flow structure where the program executes instruction in the order in which they appear. It executes them one line after the other, in the order you've written them. Key points. All instructions are executed one after the other. No decisions are made. Everything is executed in a linear fashion. Example of sequence. All the codes that we've been writing and we've been reading, I've been working with, they are examples of sequence structure. Right. Now, in this example, the program starts by setting x to 5, assigning the value 5 to x, then assigning the value 10 to y, then it calculates the sum of x and y, and then assign the result to result, the sum, the addition, whatever you get there, it assigns it to result. Then finally print that result. So you can see one after the other, linear, in a linear fashion. So flowchart for sequence, you have start, statement 1, then statement 2, statement 3, then end. So that is sequence. Selection structure. Selection structures allow a program to make decisions based on the evaluation of some certain condition. The program can choose one or more paths to follow. So program is not restricted to one thing. It has different paths it can follow based on the evaluation of some conditions. So there are several types of selection structures in Python. We have the if statements, we have the if else statements, then we have the nested if statements, we have the match case statements. Right? So these are the several types of selection structures in Python. I'll pick them one by one and see how they work. The if statements now. The if statement executes a block of code if a specified condition is true. So the if statement is going to execute one block of code if you know that all this is based on the evaluation of the condition. If the evaluation of that condition is true, it's going to do one particular thing. It's going to execute a particular block of code or lines of code. If the condition is false, it's going to skip that line of code and not execute it. You can see that it is not sequence anymore. Sequence does not skip. Right? And the syntax for the if statement is if you're just making assertion. If then your condition. So if that condition is true, you're saying if this particular thing that I've written here, this condition, if it evaluates to true, then that is when you will execute these codes. If not, just keep them and move on. Right? So that is if statements. You have your if, then you have your condition. We'll do examples. I'll write the code. So we have x is equals to 10 now. We assign 10 to x. Now we are checking. You can see if x is greater than 5, you can see that's the condition. It evaluates what? True or false. If x is greater than 5, can either give you true or false depending on the value of x. Then that means the following line. We want to print x is greater than 5. So since the x is 10, x greater than 5, 10 greater than 5, that will give you what? True. So since it is true, you are going to what? Print x is greater than 5. Let's say for example, x is what? X is 3. 3 greater than 5, that's false. Then you are not going to do that line. You are not going to execute, the program will not execute that line for the if statement. So the flow chart for if statement now. Start, check condition. Then you can see that it's not straight. It has two parts. The truth part and the false part. If that condition is evaluated and it is true, then execute, run these codes. If it is false, skip them and end, or go to the next code after. So that's if statements. We'll look at if statements, if else statements. We'll write codes. Write codes in this class. Then if else statements now. If else statements. We have talked about if statements. Now we are talking about the if else statements. You are adding else to the if, and you will see what that means. So the if else statement allows the program to execute one block of code if the condition is true, and another block of code if the condition is false. For just if statements, it is only if the condition is true, you have a block of code that will be executed. If it is not true, nothing happens. It just moves on. But if else gives you the power to execute some other statements if that condition is false. So if it is false now, I want to do this instead. If it is true, this is what I want to do. If it is not true, this is what I want to do. I just don't want to skip. I want to do something if it is false. So that is where the else statement comes in. The else statement is for the false value, and the if statement is for the truth value. So if, then you have your condition. If that condition is true, then you are going to execute a block of code. Now, else means else or else. If the condition is false now, execute this block of code. So an example again, we have x equals 3 now. If x is greater than 5, then execute this block of code. Else, which means if x is not greater than 5, if that condition is not true, if it is false, then this is what I want you to do. So since x is 3, is 3 greater than 5? No. So we are going to move to what? The else part. And else is going to print what? X is less than or equal to 5. Right? If x is 10, for example, 10 greater than 5, that will give you true. So since it is true, it is the condition of the if, it is the statement for the if that is executed, which means x is greater than 5 is what will be printed. And the else part will not be printed. You can see that it's not sequenced anymore. So it has jumped one for another one. The flowchart for if else statements now. You can see for the if statement, for the first part, it just skips. But for the if else, for the first part, there's some code for it, some statements, code for it to execute. So both of them have as execute, executing different things, doing different things for the result of the condition, for the different result of the condition. So now we have nested if statements. Nested if statement. There is one other structure that is not being talked about here. Maybe after my nested if statement, I'll talk about it. So now nested if statement. Now, a nested if statement is an if statement inside another if statement, right? You have an if statement. You have another if statement inside it. So the code you want to run inside that if statement is another if statement. There's another if statement inside it. It can be in the if, it can be in the else. Both of them are together. If else, they are together. And when we say if statement, we mean the two. So if else statement in this case, it allows for more complex decision making by testing multiple conditions. So you can see we have condition 1, we have condition 2. So if condition 1 is true, then we check if condition 2 is true. If condition 1 is not true, we just go to the else for condition 1. You can see that there are 2 else there, one for each of the if. So if condition 1 is not true, you just move straight to the else, because that means the code inside the if statement for that condition 1 will not even be executed at all. Now, if condition 1 is true, we enter that block. We enter the block of the if statement for condition 1. And inside it, we have what? Another if statement, nested. One if statement inside another. And this if statement is checking condition 2. If condition 2 is true, the if statement for the condition 2 will be executed. If it is false, it is the else statement for condition 2 that will be executed. So now, an example. We have x is equals to 12. If x is greater than 10, right? If x is greater than 10, then we want to check if x modulus 2 equals to 0. This is just the simple way to check if a number is even. You do x modulus 2. X modulus 2 is doing what? Remember your even. Even number is any number that when you divide it by 2, there's no remainder, which means the remainder is 0. So you check the remainder of the division of that number by 2. You check if the remainder is going to be 0. That's how you determine if it is even or not. If the remainder is 0, it is what? It is even. If it is not, that is the else. It is what? It is odd number. So now, an example here is we are checking if a number is greater than 10. If it is greater than 10, we are now checking if it is even. If it is even, we print it that x is even and greater than 10. Else, if it is not even, it is what? It is odd. You either be even or you be odd. Else, we print x is odd and greater than 10. If the number is not even greater than 10 in the first place, we just print x is less than or equal to 10. Because the only way you enter that nested if is only if your x is greater than 10. If that condition 1 is true. If not, you just go to the else statement for condition 1 straight up. So you see this if statement, this first if statement, this is the else statement for it, which means if this is false, this is where it comes to. Now, if this is true now, you enter this block, you can see that this block is kind of inside it, right? So now, we are now checking again if that x, if that number is even by dividing it by 2 and checking if the remainder is what? Is equal to 0. If the remainder is equal to 0, it means that what? It is even. And that's what we are doing. If not, if this is false now, then this is where we come to. Because we're already in this if statement and this else is gone from that point. So this is nested if. Now, what I want to talk about is we also have else if to check multiple conditions. This is nested if. There's an else if to check if you have multiple conditions to check, right? And they are independent. You use else if. So we'll see some examples too. So you have if, you have else if, then you have your else last. So you can have if x is greater than 10, then print x is greater than 10. Else if this first condition is not true, I want to check another condition entirely that is independent of this first condition. If x is greater than 5, print x is greater than 5. Else if x greater than 3, print x is greater than 3. Else, in the end, if none of the three conditions, if none of them is true, then it will be false. Then print x is less than 2. Right? So that is how you use else if for multiple conditions that are independent. Now, in this case now, the programs first check, okay, I've explained this. Let's look at the flowchart for the nested if. You can see that you have start, you have your first condition, you have your condition 1. Depending on the result now, true. If it is true, you have another condition. So this is what is happening. Don't mind the diagram. So this is for the true. And this part that is just going outside is for the false. So don't mind the way it is looking. So now, if this condition is true now, we have another condition, condition 2. So we check the condition 2. If the condition 2 is true, we are doing what? We are printing odd, even, we are printing even, sorry. If it is false, we are printing odd. You can see that. So that's an example of how nested if will look like. For else if, it's not just going to be straight like this, right? You are going to have your condition. If it is true, you have something you are going to do. If it is false now, you are going to check another condition. So that condition is going to be true or false too. If it is true, you have something you are doing. If it is false, you can have another condition to check, right? Then that condition, if it is true, you do something. If it is false, you now do the else. So that's how an else if statement is going to look like. So I'm sorry that you can check it out online. Sorry that it's not in these notes and I cannot write anything on the screen for you. So now the match case. The match case structure in Python was introduced in Python 3.10. It's uh very recent. It is similar to the switch case statement in other languages. So other languages they use switch case. Python uses match case. So it's similar. It allows you to match a variable against several possible values or patterns. Right? That's what it does. So you can match variables against several possible values or patterns. So you have your match. This is the syntax. Your match, the variable you want to match. You know your variable will hold a particular value, right? So you now want to check if the value is this first one, then execute this code. If the value is this, execute this code. If the value is not any of these two, the default, execute this code. Let's look at an example. Now our variable is what? Day. The value is what? 2. Match day, the variable name. Then you are going to be checking. If the value is 1, print Monday. If it is 2, print Tuesday. If it is 3, print Wednesday. If it is not any of 1, 2, 3, print invalid day. And since the value is 2, it will match this case of 2 and print Tuesday. Let's assume the value is 4. It will not match any of this case. So it will fall to the default and it will print invalid day. If the value is 1, it will match this case and it will print Monday. So that's how match case works. It's very straightforward. And this is the flowchart for match case. You also have match variable, then the value you want to match and what you want to do per value. So lab activities. For this lesson, we'll implement and practice our selection structures through hands-on exercises. First, we have an example, grading system. So we are going to write a Python program that assigns grades based on student marks. You can see that we are using else if here, right? So the else if that was not really talked about, you can see that we are using it here. This is else if, else if, and that's how you write it. So we have different conditions. You can see each elif is also checking conditions and they are independent. So this one is checking if max is greater than or equals to 90. This one is checking if it is greater than or equals to 70. This one is checking if it is greater than or equals to 50. And there is else for if none of this condition is true, you come to X, it will do else for you. So now there are many things that we'll talk about in this code, right? So write a Python program that assigns grades based on student marks. Now you can see your variable marks. In this case, we are just not putting a value straight like 70, 80, 90, 75, 55, 45 or any of those things. What are we doing here? So let me explain this line to you. So we have two things going on this line. The first in the brackets you can see is inputs enter your marks, right? You can see inputs, then parentheses, and in between it there is a what? This is a string because it's in quotes, and it says what? Enter your marks. This is how you collect user input. So any place in your code, maybe in your exam, and it's asking you that, oh, ask the user for something, collect user input. This is how you collect the user input. Now, there's a caveat. You can see that there's still something outside that is encompassing the whole input. So what this does, what does it do? Input, anytime you get user input, you understand, from using input, this enter your marks is what we just print on the user screen. You know, you want them to give you something, so you are going to tell them what you are expecting them to give you. So, and that is the message that will be here. So the user will see enter your marks, and then there will be chance for the user to enter something. So now this int part, what is it doing? For input, anytime you use input to get the user input, it will always be in string. The data type of the value that the user is inputting will always be in strings. So even if the user input 50, that 50 is going to be a string. So this int is what we are using to do what? To convert it to the appropriate data type. So for this case, we want to convert it to what? To integer. So here casting. So you cast from one data type to another. So we are casting string, which means we are converting a string to an integer. Input will always get you a string. So converting a string to an integer, you use int. Remember your int. If you want to convert the string to a decimal number, you use what? You are going to use floats, right? And if you want to convert that string to boolean, you are going to use bool. So in this case, the user input, we want to do what? We want to convert it to integer because that's what we need. And the input is string. If the string that we need, like let's say we're asking them for their first name, their last name, their middle name, and all of that, those are in strings normally. We don't need to convert them. We use them as we get them. But in this case, we need it to be integer. So that's why we are converting it to integer, right? So now, whatever the user has now given us, we'll now go into our selection structure. We'll first of all check, is the value greater than or equals to 90? If the value is greater than or equals to 90, it's true, and we execute the uh the statement for that particular first condition, and that will be all. We skip the rest. So once you get your true, you execute the statement for that true, for that condition, and you skip the rest. So let's say, for example, it is 91. We'll print grade A. All these other parts of the if statement will be skipped. Let's assume it is now 55. We are going to check 55 greater than or equals to 90. No. We move to the next condition. 55 greater than or equals to 70. No. We move to the next condition. 55 greater than or equals to 50. Oh, true. It is. We are going to print grade C and then skip the rest of the selection structure. So that's how it works. So you can see that we are making decision based on the result of conditions. Now, there's another example here. Even and odd checker. You want to check if what? A number. You can see that we're also asking the user to input the number again. So whatever number that the user inputs, we are going to, you see, because it's a number that we need, we are doing what? We are converting it to integer. So whatever the number the user inputs, we are going to check, is this number, when you divide it by 2, is the remainder 0? If the remainder is 0, we print what? We print that the number is even. So this print format is different from what you've been seeing, right? It's different from what you've been seeing. So we print number is even. Else, you can see, if this condition is false, we print what? Number is odd. Write the code. This is for the leap year checker. So you can look at it. You can see that for this leap year checker, our if statement is what? Is a compound comparison condition. So you are checking more than one condition. This is one condition. This is another condition. And this is another condition. You can see how there's and between the two of these, and this whole thing is inside parentheses, so that this what will evaluate on its own regardless of this or. And when it is done, this will also evaluate on its own. When it is done, the result of this and the result of this, you perform the or between them. So if this is true and this is false, you get true because of the or. If it is false and false, you get false. If it is true and true, you get true because of the or. But for this part, there's and between them. So for it to be true, this has to be true and this has to be true. So if you look at it closely, see that it's a bit compound, and this is how you even write conditions in real life, because sometimes you have to compound uh, comparisons like this. You still write simple conditions like this ones too, actually, a lot. So now, let's get into writing the codes and start with this. So I'm going to create a new file again. I'm going to call these selection structures dot py. Remember, dot py. Now, first thing I want to do, score variable to collect your score. Int, because I'm going to convert it to integer in the end. Input, this is how I collect user's input. You will see what will happen when we run the code. Then the message I want the user to see. Enter. Make sure you remember to put it in quotes because it's a string. Enter your score in SEN 111, for example now. So now, if enter your score, this will ask you for your score. Now, we have your score. We now want to check. We want to use your score to determine your grade because that's how it is done normally, right? We have A, B, C, D, E, F. Each of them will have their own condition. Now, if score for A, what is A? For you to have an A in the university, tertiary institution in Nigeria, you have to have a score of 70 and above. So I'm going to check if that your score is what? Is 70 and above. And how would I check that? I will check by using score greater than or equals to 70. So that means if it is equals to 70 or more than 70. So score greater than or equals to 70. So I want to print, print grade A, which means what? You scored an A. Now, I want to check another condition. So I'm going to use what? Elif. So I'll do elif. So else if your score is greater than or equals to 60, that is B, grade B. So now, you might be asking me that this second condition, if the score is 70, you understand, that's grade A, but to print grade B, we are already taking care of any score that is 70 and above here. So if your score is 70 and above, this is the condition that you will match with. And as I've explained, once you found a truth condition, all the remaining parts will not be executed. So this will be executed for somebody that has 75, grade A, and it will never come to this part. This is for anybody that does not fulfill this condition. So we check, is your score greater than or equals to 70? If it is not, we also now check, is it greater than or equals to 60? If it is, we print B. If it is not, we check again. If it is greater than or equals to 50, we print C. Right? If it is not, we check if it is greater than or equals to 45. So 45 to 49 is D. Now, we are still not done because this AI is not a Nigeria AI, so it does not understand how it works here. So we are still now also going to check if your score is greater than or equals to 40, you have E. If not, then F. You can see that we are checking for the condition for grade A, then the condition for grade B, condition for grade C, condition for grade D, condition for grade E. But you know, since if you don't fulfill any of these conditions, you definitely have F. So we don't need to check for the condition for grade F. We just say if none of these conditions are true, then F loading, you is your grade is F. You failed, which means you have a score that is less than 40. And you know F is what? 0 to 39. You get me? So this is a selection. This is selection structures. You can see we have conditions that we use to make decision. So the decision, this decision you are looking at here is the simplest. You are just printing something. You can do a lot of things. So for example, let me add a nested if now. Let me add a nested if now. So I've now printed grade A, and I want to check if your score is greater than 90. I'm printing SEN on one color. Right? So if you have 90 and above, you're a scholar in SEN 111. You can see that this is a nested if, right? There is no else. I just want to print that you're a scholar if you have score greater than or equals to 90. If I want to do something else, if your score is not greater than or equals to 90, I can do something else. I can say, I can do else and say, try better next time, or you tried excellent work, you could have done better, and all of that. So now, let's say this is a proper software and we want to give scholarship to some set of students by using their mark. So I can easily grade you, and then I'll check if your score is greater than or equals to 90 and write the code that will grant you the scholarship. Maybe we want to give you 50% off for your next school fees. So I'll write the code inside. You can see that that code will be more than just a print statement, right? Aha. So that is an example of what I want to show you. So let's run the code. Let's run the code. Remember, I'm in my SCN folder, and that's the same folder that has selection structure. So if I do ls, you can see that I have selection structure now. I can now run it. Python space selection structures.py, the full name. Now, when I click enter, what do you suppose will happen? Let's look at the code. When I click enter, the first line is what? Asking the user for some input, right? It's asking the user to enter their score. So the user will see this prompt, enter your score in SEN 111. They will see it. They will see it. And it will ask it, there will be a sign that they can enter something there, right? So this is where you enter the score. So that's the first thing that will happen. So after you enter your score, the next thing that will happen is we'll now check. We'll use our selection structures to determine the grade that you've gotten based on the score. So let me press enter. You can see that the first thing it is doing. Let me make this a little bit. Let's make it a little bit bigger so that you can see. Excuse me. All right, so you can see the first thing is asking me to enter my score in SCA 111. And you can see that it's not going any further. It's not running the rest of the code. It's going to ask me for my input first. So then I say, okay, I have 39. 39 that I had. What do you take it to print? Grade F. Because it will check the first condition, that will be false. It will check the second, it will be false. Third, until the last condition is false. Because 39 is not greater than or equals to 40. And what happens? Since all the conditions are false, it will go to the worst, the else part. of the code. Right? That is basically what will happen. So let's run the code again. So this time I had 85. What are you supposed to print? To just print what? Grade A, grade A, because I have 85. So it checks, is 85 greater than or equals 70? Yes. What does it do? It prints grade A. Then it also checks, don't forget, it also checks, is 85 greater than or equals to 90? It is not. So it does not do anything because there is no else there. If there was else there, it will have done the else part because that is for the first value, but there was no else there. So this is how if else statement works. If statement can stand alone. If statement is the only one that can stand alone and does not have anything else. If has to have an if statement. You start with if statement before you have elif. Else statement. Else statement also needs to have if statement. They can't stand alone. So elif and else cannot stand alone. They need the if statement. But if statement can stand on its own without having anything else. So as you can see on line 5 and 6, you can see that the if statement is alone. There's no else, there's no elif. So but before you can have elif, you have to have had if statement. And before you can have else, you need to have had if statement. So now let's see, my grade is now 93. Let's see what will happen. You see, grade A and SEN 111 scholar is printed. So it checks, is 93 greater than or equals 70? Yeah, it is. So it prints grade A. So first of all, your grade is already A. Then it now checks, are you an SEN scholar? And the condition for that is your score has to be greater than or equals to 90. The score is 93. Is 93 greater than or equals to 90? Oh yes, it is. It prints SEN 111 scholar, as you can see here. So that is how it happens. So this is an example of your selection structures, your if and else statements. So now let's look at the match case. So now we are done with the if else statement. D. Aha. You can see that I want to now take another input from the user, asking them to enter the day of the week. I'll now use match case. You can use if statement, but I want to use match case. Match day. If it is Monday, then print this. If it is Tuesday, print this. If it is Wednesday, print this. If it is Thursday, print this. If it is Friday, print this. Saturday or Sunday, print this. Default, you can see. So sometimes you might want to check two things. Two things might have the same thing. Like, for example, let me do TGIF. So, for example, you want to check two cases and you want to do the same thing for that two case. So you can do this case or this case if it matches any of these. So I'm going to add a lot of matches to this because the user can enter different things, right? So I can do a lot of things. So when I get the user input, I can try to make it lowercase. I can try to make it lowercase. You can see because it's a string, it's already bringing examples of the the operations you can perform on strings. So you can see capitalize, that's an operation you can perform on string. And what will capitalize do? To make it uppercase, right? That's capital letter. So, but I want to lower it. And then capitalize. So this capitalize means it is just the first what is it called? The first character, the first alphabet that will be uppercase. That's what it will do. is capitalized, we capitalize the first alphabet. If you want the whole of the word, the whole of the string to be uppercase, that will be dot upper. It will be upper. So capitalize will only do for the first. So let's say, for example, user enters something like this, Monday. It will give you what? Monday like this, because it first of all turn this whole thing to lowercase. So this is what happens. First of all, turn everything to lowercase like this. Then it will capitalize the first letter. So that's what capitalize does. So that's what I want to do. So when I get the user input, I want to turn everything to lowercase first, then capitalize the first letter so that I can get things that looks like this. So now I don't want to just stop there. I want to have something like this because people can do mon. I want people to be able to do 3 letters instead of typing the whole thing, because typing the whole thing might be stressful for you. So 3 letters. So I want to allow people to be able to type 3 letters for the day of the week. So if it is Monday, you can type mon. You understand? So I am trying to take care of everyone. So if somebody types MON, I know that it is Monday. Because without that, it will just go to that's not a valid day of the week. And I don't want that to happen for user experience purposes. So let's run. It's the same file. So let's run the code again. What do you think will happen? It will ask me to enter my score because it's going to execute from top now. So after I entered my score, it will it will run this selection structure. Then to move to this when it's done with this. So if I say 90 now, it will do this part, it will skip all these parts and then move to the next statement. So let me do 99. You can get 99 in the course. So now you can see it prints what? Grade A, and you are a scholar of SEN. Then it skips all this, right? Because there's already a true value and it's done with that. So then it comes here and is asking for the day of the week. So today's date is Monday. Today's date is Monday. So I can either do Monday, Monday, Monday. So as long as what you are typing is the correct spelling, the case does not matter, because what I'm doing is I'm getting whatever you've typed. I'll turn it all to lowercase, then I'll capitalize the first word, the first letter. Sorry. So whatever case you are typing does not matter. So I'm not that lazy, so I can do Monday. Or let me do Monday in lowercase like this. And you see that it works. It's the start of the week. That is what we are printing for what? For Monday. You can see how that's how match case works. You can see how the if, else if, elif, and else statements works, the nested if, and the match case. You can see how they all work. And you can see you've seen examples. I'm talking about variables. You can see that this is a variable. We are storing a particular value in it. Score is a variable. So we've talked about variables. We've talked about constants and operators. You understand how we use them and all of that. So I employ you to do a lot more practice. I employ you to do a lot more practice. Look at past questions too. Look at past questions. Your test questions are also there for you to practice. There are practice questions in your notes. So you look at all of them and practice them. So we've done some now. You can look at this. You understand. And then look at this too. And work with them. Right? Uh So the next control structures is iteration and modular programming, which will not be chance to look at. But you can look at this after your exam yourself. You can look at it and try to understand what is going on here. There are a lot of resources out there that can help you too. And if I have enough time, I might make another video or we'll have a class to look at the remaining concepts that we're not able to cover. So we only have week 6, 7, and 8 left to look at. And once you've built on the foundations, because this is foundations, uh, the sky is the beginning. You can do a lot with programming. You can see a lot of things that have been done with programming. Even the video that I'm recording, I'm using a software that was programmed, right? Uh, our material and what we are using to display it, programmed. Your phones, everything runs on programs now, everything. So if you have any questions before your exam tomorrow, you can just text me or ask your seniors, people like um, uh, Rahman in software engineering 200 level, or Adam, or people your seniors in 300 levels too. They can guide you, they can help you. So I hope this class was enough for you. Please try to watch the video to the end before your exam. It's just an hour and a few minutes. All right, thank you. Have a good one.